In this tutorial, we're going to take a look at debugging node.js applications that run in and out of containers. I have an M1 MacBook Air, and historically my debugging experience with Visual Studio Code has been a great one. I would like to have that same experience using Visual Studio Code to debug my Node.js applications that run in containers. But to be successful at that, there's a couple of things I need to understand. The first of that is how Node.js debugging works, and more specifically, how that debugging works when using an application in and out of a container. That container may have been started by different runtimes. There's, Docker, which most of us are familiar with. There is an alternative called podman.io, or Podman, at podman.io. And it is for all practical purposes, a drop-in replacement for Docker. So we're going to investigate on how to set up debugging using Podman and Docker on your Mac. So that's the first thing you need to know. How does Node.js debugging work? And we'll cover that in subsequent sections. The second thing to understand is, how do you set up Visual Studio Code to provide an integrated experience when you're doing that debugging? And that's a very important part of creating a good experience. So that's the second thing that we will need to understand and that we will also look at in this tutorial. What is the end game? Well, to tie back how I was talking about my great experience with Visual Studio Code, we want to debug containers and have that same F5 experience. Now, what do I mean by an F5 experience? Let's bring up a terminal to illustrate. Let's create a folder. And we are going to open up Visual Studio Code into the root of this folder. And let's create a JavaScript file that has some simple code, which we'll cut and paste in a moment. This is very simple code. It really just prints the system information. And when talking about the F5 experience, well, what is that? Well, let's set a breakpoint. Let's set 2 and press the F5 key. Well, that's the experience. It's very little work, very little effort, and before you know it, I'm stepping through my code. Now, wouldn't it be great if we could do that in our containers? So I'm building on my Mac, I'm developing on my Mac. I have a remote virtual machine or a remote machine that has the container. And yet I'm having this great local debugging experience and actually running and testing my code in that way, just by pressing an F5 key. Well, that's part of the end game of this tutorial, is to show you how you can set that all up. So that's the F5 experience. We want to be able to do that with Docker. So if you've got Docker Desktop on your Mac, we'd use that. And there's some plugins for Visual Studio Code. And without Docker, which means that you don't have Docker Desktop installed on your machine, and you have a remote virtual machine that is set up. And we use Podman for that. Now you can use Podman if you're developing on a Linux host, that's simpler, but this applies to that as well. My environment is an M1 MacBook Air, so it's not an Intel. And so I'm using Parallels for my virtual machines, and I have a stock Fedora virtual machine. I also have a separate Intel NUC server that has a stock Fedora 34 So you can use either virtual machine to set things up. But the whole point is let's focus more on code and less on containers. This, after some initial setup, the experience can be really great. The simple example that you saw in the previous section is one of two simple examples that I will be using to illustrate the points in this tutorial. I just would like to point out that we're not using package.json, we're not using node modules folder, because we're not pulling any external modules in. Trying to focus on just what's built in node.js from a debugging perspective to illustrate the point. And just to remind you, the first script which we just saw prints out host information and exits after completion. The second example is a HTTP web server. So it'll stay running until it self-terminates. The reason why I include both of these examples is because when you debug both, they've got slightly different switches for the two scenarios, where something self-exits and something at least terminates as soon as completed, or you have something like a long-running process, like a web server. And so it's just shown here for clarity. You can see that it terminates when it receives a queue option. So I just would like to point that out before we start. If you want to look at the code, it's available at this URL in this GitHub repo. And just remember that I'm assuming that SSH has been set up as described in this tutorial. So when you run it, if you haven't done those steps, it won't work. The JavaScript debugger is part of the embedded V8 JavaScript engine. It's called the inspector, and it is the same engine that runs in Chromium-based browsers. That includes Chrome, Edge, Opera, Brave, and a handful of others. When using this embedded debugger that is part of this JavaScript engine, the key thing to remember is that it exposes an API when activated. And this API is a debugging API. You talk to this API using the inspector protocol, which is a protocol developed by the Chromium developers. What this API does is it exposes an endpoint, a WebSocket endpoint, at some IP address, but the default port of 9229, and then a unique global identifier that identifies a debugging session. So that's the endpoint that is exposed. If you want to watch for active endpoints, then you can use the about inspect URL in any Chromium-based browser, and it'll show you any active endpoints. Let's just take a look at that to illustrate. Let me bring up a terminal, and let me bring up a Chromium browser. There we are. If I go to Chromium browser and I type about inspect. See that configure button? Open that, type in the IP address that you want to monitor, the default port. Now, if you're monitoring for a remote machine, you'd put the IP address of the remote machine. Make sure that that little discover network targets is enabled. And that will result in a little area here below that'll monitor for any active endpoints. Now, at the terminal, I'm going to use the node inspect flag. I'm not going to run any scripts. Actually, let me just make sure I'm in the same folder that we were working on in earlier on. Right, so I'm going to type the node inspect flag. What this node inspect flag does is it activates the Debugger API endpoint. If I do that, you'll notice that the remote target has a little node blurb there that allows you to inspect and open up an inspector client. And that inspector client, when opened, completes the circle of a debugger session, which means that the API endpoint is exposed from Node, and the debugger is in the server side of that equation. Then I have a debugger client, which is opened, and when that debugger client connects, it tells me the debugger is attached. If I shut down the debugger client, see how it says the debugger is ending, but the API endpoint is still there because the server side of this equation is still active. The API is still active. If I open the client again, it comes and goes. So that's how you activate the API endpoint. And the browser, this little status page, is basically monitoring any active endpoints. If I now terminate Node, right, that endpoint is now gone. So that explains the API endpoint that is exposed. And that is what I'm talking about when we say that the API is activated and the API is exposed. The about inspect watches for activated endpoints. But then we had a debugger client, which we looked at the Chromium default debugger client, which is Devtools. That came up. But without that debugger client, right, the debugging session is pretty meaningless because you can't interact with the debugger. But there are three other debugger clients I just want to draw attention to. The first is NDB. You can install NDB from npm and think of it as Devtools without the browser. So you can just launch a script directly and it'll bring up that Chromium Devtools type experience. But interestingly enough, Node not only has the inspect flag, but it has a built-in debugger client as well that is terminal-based. So it's not going to be a visual experience. It's going to be a terminal-based experience. Let's take a look at that for a moment, just to illustrate. If I am here, I say node, and I give the inspect command. What that really is, it tells me actually that the inspect is a module. It's a built-in module that's part of Node. You know how I earlier on illustrated by running that script which we created? Notice if I just use the folder name, it knows to load the default index.js because that's the default module name for a folder. But that'll load that module, but it's an external module. Well, Node has several built-in modules, and inspect is one of them. What inspect does is it's a JavaScript-based, terminal-based debugger client. And if you run that command, it'll tell you, oh, these are the options that you use for this command. Notice how one of the options, I can debug a script. So let's try that. Just like I ran the example before, now I'm going to debug that example. And suddenly I'm in a terminal-based debugger where I can step through the code one line at a time. I can do a number of things that's a little bit beyond the scope of this, but one thing I can also do is I can see what scripts are loaded. And notice how my default module source is included in that. It also has a REPL. And the REPL allows me to inspect the internal state of the process being debugged. right? The debuggee. The debugger in the context of that would be the node server/client combination. It's a little bit different to if you're debugging, let's say, a Go process with the Delve debugger, where the debugger is a self-contained utility, right? And the process being debugged is a binary. The difference here is that the node debugger is built into the node binary. It's part of the V8 JavaScript engine, and so it needs this client side to complete the equation. In that REPL, I can just terminate it. Anyway, I don't want to get into that more too much, but that's the node inspect option. Let me just close this here for a moment. We're going to come back to this in a moment. Right, so that's node inspect. And then there's Visual Studio Code, which is the primary goal of this tutorial, to show you how to set up integrated debugging. Earlier on, we pointed out, here's my script. When I click F5, all right, I'm debugging node, and I am functioning, the VS Code is functioning as a debugger client. It's connecting to the API endpoint. It's what starts up the node process on the local machine, and then it connects and provides a nice, complete, integrated experience. The goal of this tutorial is to take this code, these applications, and put them in a container in a remote VM and experience the same debugging experience as if I were debugging it locally like I am right now, with the same experience. So that's the VS Code debugger client. It helps to get the terminology right here because, for example, the word inspect is used in such an overloaded way. We've covered node inspect, as a flag. We've covered node inspect as a module, think of it as a command. All right, and it's kind of like a verb. You inspect something. But there's another way to activate the debugger, and that's activate the debugger after the node process has started. So if I run a script and I want to activate the debugger after it's run, then I can do that too. So let's just take a look at this. So I've got node. I'm going to start it. I'm just using node with no modules here. Now what I can do is I can use the inspector module. Like I was telling you, it's overloaded words, right? I do a require, and I load the internal inspector module. When you use the inspector flag, the -- inspect, it internally is effectively doing what I'm doing now at runtime. And I say open. Let me just bring up the browser that's monitoring. Right, so I'm monitoring port, the local host. So when I open the inspector in this way, I can say port 9229 and the local IP address, right? Notice how it has the same impact as if I started node at startup time with the inspect flag. I can then also close it. Now, if I wanted to, let's just create a new window here. Right, so this node process is still running. Let's see what the process ID is. Right, so there is the local PID is 94438. If I use the node inspect, we'll look at these options. So I use the script earlier on, where I just started the script immediately, it effectively launched another node process and behaved like a debugger client in its own node process. There were two processes involved. The scenario I'm looking at now is I have another node process running and I'd like to connect to it on a particular port, right? So the debug isn't running, all right? So I need to do that. So let's require, all right, we're going to use the inspector here. I'm going to open port 922.9 and localhost. All right, so that's going to go into listening mode just like we normally do here. Now, instead of clicking this little link and opening up the Chromium debugger client, I'm going to use the node inspect debugger client. And in this case, I'm going to use the port. Oh, what is that? Let's see why is it doing that? What is it doing? Of course, node inspect command and port option, right? See how it has the same effect? Debug is attached. Now I've got this process, right, which is the debugger process. And if I go into the REPL and I go process.pid, look at that, it's the same, because I'm debugging the remote one, even though it's a different process. So the point I'm trying to make is I can use the node inspect debugger client to connect to a local debugging session or even a remote one. In that case, I would use the host and the port as an option. So that's the debugger client where I am connecting to another node process at a particular port, but it's a terminal-based experience. Let me just exit this now. I'm going to shut down the debugger, and you can see the debugger is ending, and I can exit Node. Actually, but before I do that, there's one other way to activate the debugger, and I think this you will find interesting. So we know that the other process is 94438. I can also send it a kill signal with sig usr1 and give it the PID. And what that's going to do, instead of shutting down that process, it's going to send it a signal. Now, obviously, this is a local with the debugger and the debugger on the same machine. This is when this scenario works. So this has got limited application for containers, except that if I want to do a Docker exec or a Podman exec into a remote process to turn on the debugger after that process is started, then I could also do something like this. Oh, it was already running. Let me close it first. Let me close it first. Right, so this is code. So I could have code that's doing what I'm doing right now. If I send it a kill signal, then it's going to activate that debugger just again. So there it turns it on. So there I've covered a couple of ways that you can activate this API endpoint. You use the inspect flag. You've got the inspect command where I launch another process. I can send it a signal. And the point that I want you to remember is that the node.js debugger is just an API endpoint that you connect to with a debugger client. And there are lots of different clients. Let me reset this for a moment. just for clarity. So that's the debugger client. So that covers the JavaScript node debugger. It's a client, it's an API endpoint, and it's the V8 engine. To visually recap what was covered in the node debugger, I think a diagram says a lot. Let's take the example where we're running a node app.js. When we run a node process, just like I've explained, the embedded V8 engine, the yellow area, is part of the node process. It's embedded into it. The green is the V8 JavaScript engine. So it's going to run my app.js and do whatever it does. When I activate the inspector, which is the debugger, then that's its own module inside Node.js. And just as I demonstrated how you can open the inspector by giving it a port and a host, what that is effectively doing is it's opening up this API endpoint of the node process. I can also activate the inspector using the kill sig user1 signal. That's if I want to activate the inspector after the process has started. To activate the inspector at startup time, I have the inspect flag, which is the inspect with the double dashes before it. There is one that we didn't cover, which is the inspect break flag. All that does is, instead of just activating the inspector, it stops at the first line of execution of a script. So we weren't executing a script when I was activating the debugger, so I didn't show you that, but we'll get to that. Because the inspect break is actually the one that we want to use when debugging containers, because we want to stop as the program executes. Then we spoke also about the various debugger clients. We had the NTB, we had the Chrome developer tools, and then we have Visual Studio Code. We went into quite a bit of depth about how the node inspect command would launch a node process which functions as a debugger client to the process. Now, when doing all of this inside a container, it's really choosing where to run the binaries and to make sure that the correct API endpoints are exposed through the container and the correct volumes are mounted so that the container can find the files that it's trying to debug. This is an important consideration because there are multiple ways to expose a volume. What we're trying to do is we want to use our local folder on a Mac. We want to then launch the container, which then binds to that local folder on my Mac, so that I don't have to copy files and move files around. It just creates for a better, more integrated experience. But the things that you have to pay attention to are ports, volumes, and of course IP addresses. So we want to make sure that the adapter of the container is exposed to its host, which in turn is available to the debugger client, which runs outside the container on a local Mac. The default debugger ports, can be used. What we're also going to look at is it possible maybe we can tunnel through all these options onto the local Mac to provide a really seamless experience where our volumes on our local Mac are automatically taken care of and mounted in the remote container. In previous sections, we saw how if I want to run my app and get the system information, I do it like that. Invoke node, give it the location of the script. Now what if I wanted to run that in a container? How would I do that? Well, you can use docker run command. So for the purpose of this part of the demonstration or tutorial, I have Docker desktop enabled on my Mac. So it's installed and it's running. And that gives me access to Docker. When I get to the examples where we talk about Podman, I'm going to turn Docker off so that I can't use it. Anyway, let's see. So we'd use Docker run. I do want a terminal, an interactive terminal, so let's specify that. I do want the container to remove itself after it exits. I do want to give it a name, and let's call it my node. I do want to give it a host name. Let's just call that N1. I also would like to specify the working directory that node will start as. So I'm going to actually choose the current working directory that is on my current machine. I'll explain that in a moment. And in order for that to work, I need to create a volume where I map the volume, the location where the code is going to be in the container to be the same as the location on my local Mac that I'm running this app from, which is ~node app. So the way I do that is I map a volume that corresponds to the local volume. Now what I do is I specify the node container version that I want to run, and I launch node. Notice I don't have a Docker file at this point. I haven't copied files. I don't have to do any of that because I'm debugging. I'm trying to troubleshoot my app and get it working. The arguments that I'm going to give to node is going to be exactly as the example above. Now, if I do that using Docker desktop, this will magically work. And you can see that is indeed the case. I've got Darwin, which is Mac versus Linux. They're both ARM-based processes because it's Docker running a virtual machine, and this client utility on my Mac is invoking the Docker daemon, which in turn is then launching the container and giving me the same results, except for one thing, is that here the user that the app is running at is the user that it was launched as, whereas on the container it's root. At least root from the container's perspective, right? And that's not ideal. Nevertheless, one step at a time. The way that you automate these things and get things to work in more complex scenarios like integrated debugging is to understand all the small steps. And that's why I'm painstakingly going through these small steps. Because once you can do the steps mechanically, then you just bundle them up and do them automatically. And then you have a whole new integrated experience. And that's what we're trying to do here. Now, if I wanted to debug this app, just like I did when I illustrated running Node locally on the Mac, I can just use the inspect terminal debugger for starters, because that is just a terminal-based experience. And I do have a terminal set up. So this should actually debug the app, and indeed it does. So the experience is identical using Docker run. If I bring up the Docker desktop app, you can see that there is my node running. We're all happy. This is all working good. I can say next. All right, and notice the endpoint is now listening, but the address is the localhost 9229. Now, given that endpoint is exposed, the big question is can I see that endpoint on my Mac? Can I see this container running in a VM on my Mac? And the answer is no, not yet. How do we get that to work? We'll talk about that. Anyway, let me just exit out of this. As it exits, notice that the container will shut down and I'm back in the folder on my Mac. Now, Docker does some magic behind the scenes with volume mounts. Effectively, it reverse mounts it creates a kind of a volume on the VM, and it reverse mounts that onto my local folder. And then the Docker volume, the container volume, mounts to that folder in the virtual machine. When it comes to Podman, we're going to do something similar, except we're not going to use the Docker daemon to do that. We're going to use some other means, because you can do that. Now, if I wanted to expose this port, let's try something different here. Let's use the inspect flag, but let's use the inspect flag that has got the break option. And the reason is for that is I want it to break at the first line of code, because I haven't set up any breakpoints in this code yet. So I need to kind of stop at the first line of execution. But in order for that to do, I need to specify that the exposed port, the URL that is going to be exposed, in other words, this URL over here, I can't expose that to a local host in the container, because that local host in the container is not visible unless it's published, all right, or at least an IP address that is published on the client. So if I use the 0 address, then it's going to bind to all adapters in the container. And I'm going to choose the default port. But what I need to also do now, in order to publish the port, is I have to publish that port and say 9229. So 9229 needs to be visible at 9229. So this will again run in debug mode, but it's going to stop at the first line of execution. And it's going to publish those ports, bind to the local volume, set the working directory, and so forth. Run that. You can see it's paused. Great. The URL is correct. We have the right adapter address. If we bring up the container, we can see that the app is running, and it's exposed on port 9229, which is good. And the big question is it visible on my Mac? And the answer is yes, it is. So now, if I click this little inspect link, I should use the Chromium Devtools client to connect to the debugger on the server. So if I select this, you can see that I have got the code that is executing. Now I may need to add, if this doesn't come up, you may need to add the folder on your local machine that you're debugging from. In other words, this Node app, add that to the workspace. In order to do that, select this, select the location where the app is. I may be prompted to allow access. But once that folder is there, you'll notice that on the file that is being debugged, I have a little green dot, and that basically means that the breakpoints are binding. If you don't have a little green dot, it means that your working directory of node in the container is incorrect, and the debugger can't resolve the script location on your Mac. And that is why, for the purpose of debugging, let's just minimize this for a moment, I make the volume to be the same as the working directory on the Mac. When it comes to debugging node under the node user, which is a best practice, there's some other things which we'll address to do that. But for the purposes of this tutorial, this is good enough because we're focusing on learning how to debug. Anyway, I can go ahead and step through the code, and you can see everything is remote. So that's pretty helpful. So if I just continue, the script will execute, but notice that the container is waiting for the debugger to connect. Now if I shut down the debugger client, then the container will exit and I will be back at the command prompt. I can minimize this. Let's take a look at another scenario. So let's again launch the debugger in the container. So it's listening at that particular port. And let's bring up another window. Now instead of using the debugger client for Devtools, let's use the node inspect command on the Mac. Remember, it has these options. So I want to choose the port option. So in this case, I choose the port. And I'm going to say equals 9229. And look at that. The debugger is attached on the container. I'm running locally and debugging through that particular port. Now if I go into the, let's look what we've got here. The PID, all right, well, hang on a sec, I can't do that yet. If I go into because the terminal is not interactive in the remote container at this point, right? I'm using the client debugger, but what I can do is I can use the REPL on debug, all right, and I can do process.pid. And notice it's got a PID of 1. And so this tells me I'm not on the local Mac, but I'm actually in the remote container. So I can do whatever I need to do here. I can also do process and get the current working directory. And that's the path inside the container, which corresponds to my local folder that I'm using. Let's Control C to get out of the REPL. And what I can also do here is see what scripts are running and see there my script.js in the container is the one that's actively running. By the way, if you want to see what commands there are in this debugger, you can use help and it'll tell you a whole lot of extra commands. You can set breakpoints and so forth. So now you've seen the terminal debugger running inside the container and I'm interacting with it. Then you're seeing the container run in debug mode and I'm binding using the node inspector terminal debugger on my Mac connecting to a remote container. all just variations of the same theme. I'm connecting to an API point that I can reach. And that's the key takeaway to making this stuff work with remote scenarios. That monitoring that I'm looking here tells me that that API point is available. And that's how you would use it to troubleshoot it. So let's exit this. Notice how the debugger exits. And of course, the container exits, and I'm back on the terminal command line. All right, on the Mac. So that's debugging Node using a terminal-based approach, but I'm using Docker and launching the Node debugger in a remote container. Now, to get this to work in Visual Studio, all those commands that we did, the remote Docker run and so forth, you have to set up so that Visual Studio invokes those calls. And then Visual Studio, instead of a terminal binding to the Node endpoint, Visual Studio itself will bind to the endpoint. It will give you a great integrated debugging experience for Docker. When it comes to doing this with Podman, we don't have a Docker daemon. We don't have a connection point. We've got to solve a couple of issues. We have to figure out how to basically get into the remote machine. We have to then figure out how to get that machine to bind folders back onto the local Mac. We have to expose the right ports. And this could be issues. So what we do is we tunnel through this. We use an SSH tunnel, and we set up a debugging session through a tunnel where we take care of all these things in one swoop. And then we automate that tunnel with Visual Studio Code. And in that case, we can debug a remote container using Podman with no Docker presence on your local Mac. And that doesn't matter. The remote machine could be an Intel-based server, or it could be an ARM-based virtual machine running on the Mac. Either way, it'll work fine. In the next section, we're going to dig a little bit more into how to automate all of this. The first thing that we want to do when we set up automation of all these various steps is to make sure that we've got a tunnel set up to the machine that we're going to debug. What that means is that in the scenario where I'm not using Docker Desktop, but I'm using Podman, I need to set up a connection because there's no Docker daemon. So for this machine, I've got a debugger host configuration set up in my SSH. If I execute that, it'll SSH into that machine. And then from that machine, I want to be able to SSH back into the client, which is the Mac that I'm on. So you've got to be able to do this reverse. That's how you can know if this is working. If I exit this, I'm now back on Fedora host. Exit this, I'm back on the Mac. So you have to allow a remote machine to SSH onto your Mac. How do you do that? The way you do that on a Mac is you share. So if we go to System Preferences and you go to Sharing, you select Remote Login. Make sure that you've got access. So Remote Login needs to be on, and you can allow full disk access. So this is obviously a security issue. So make sure you set up, if you want a specific username for debugging, you can set it up here and set up the right permissions. But you need to be able to log into your Mac using SSH. And so you set it up in a way that makes sense for your security situation. Once you've done that, if we look at my SSH configuration, I created a couple of keys, SSH keys, using the SSH keygen utility, right? And if we look at I've got a couple of things here. I've got my normal private public keys, but I've got a debugger client and a public private key. And on the server that I'm debugging, that VM, I also have a debugger host public private key. And then I share the public key on the virtual machine, and that goes into this file, authorized keys. And then the public key of debugger client goes into the authorized keys of the remote virtual machine. And you can use that using the SSH ID copy command. Setting this all up is a little bit beyond the scope of this tutorial, but suffice to say that you need passwordless access to the remote VM, and that remote VM needs passwordless access back to your Mac for this to work correctly. If you look at the, let me just have a look here. If we look at the configuration of my SSH config, you'll notice that I've got an alias set up, debugger host. I've specified the host name of that host that I'm going to debug, what developer to use, which identity file to use, and this is important, identities only. So those 4 lines are the configuration that I'll set up on the Mac to connect to Fedora host. On the Mac, at least on the remote host, let's just look at that. All right, I can do see how that's connecting back to my MacBook Air. I'm saying user Mitchell, and there's my key identity use. So make sure that that's set up on your machine for this to work. Now, once that's set up, I can then connect in, all right, and I can access Podman. The reason I chose Fedora as the default Linux VM to install is because it comes with Podman installed, and there's no Docker on this virtual machine. The nice thing about Podman is that you can use the same commands that we used for Docker on the Mac, we can use to run containers on the server. So for example, if I say Podman run remove it IT remove the container. I'm just going to skip some things. I'm going to say node 1.6 and node. That's going to launch a container on the virtual machine, and I'm now in the node runtime environment in the container on that host. The reason why this is helpful is because if you set up passwordless access and you've got Podman, then you can do something like this. debugger host, which is my configuration for passwordless configuration setup. And now I just invoke Podman. So I'm on my Mac in the terminal invoking remote commands. So let's just see what containers we have. Oops. So there we are. So I can now launch containers in the same way I did with Docker by having passwordless configuration set up. So let's take an example and see how that would look. So instead of going to the containers, I'm going to launch Podman. I'm going to say run. So these commands are exactly the same as Docker. I'm going to specify the terminal. I want to remove the container. And I'm just going to go straight through to node. And execute node. That should work. I've got a terminal. It's running. It's going to remove. Okay, that should be fine. And there we are. So I'm on my Mac. I've launched a container in a remote host without using Docker. And that's helpful. So let's just exit. So the difference between the Docker run and the Podman run is Docker run, you're going to start Docker, whereas with Podman, you need to set up an SSH tunnel and get that configuration working. And that'll allow you to do remote automation of at least certain commands. What this doesn't address is how do I map back a volume from the Linux host back to my Mac? And that's what we're going to look at in a moment. Let's just reset this. So let's SSH into the debug host. Debugger host. What I'm going to do here is I'm going to just create a folder to illustrate something. Let's just call it P1. I don't know, whatever. Some folder. I would like to mount a folder on the Mac using sshfs. sshfs uses Fuse to basically allow one host to mount a folder in another host. And what would that look like? So let's SSH into the host. What I'm going to use sshfs. And in this case, what I'm doing is I'm mounting this folder. This folder, Users Mitchell Node app, which is on the Mac. I'm mounting that to this folder on the virtual machine. Now that folder has to exist for this to work. You do that. Now if I go into P1 and do a list, you can see that there is the source folder on my Mac, and there are those JavaScript files that we've been working on in this tutorial. So that's the first thing. Now, just let me point out, if you get a permission failed, like here, you have to unmount the folder as well. And to do that, you can use the -u option of fuse mount, and you just specify the folder that you mounted. The reason why this is important is because when you tear down a developing or development session, you're going to have to undo all these things so that the next time you start the debug in Visual Studio Code with that F5 experience that we're working towards, that everything is cleanly torn down and everything's restarted every time you start debugging. So that's important. So you'll see once you do the fuse amount and you use the -u option, you can then mount a folder multiple times. So that's how you unmount a folder. So that's another thing to take care of in the litany of steps that we're going through. The next we'll look at port forwarding. So in order to take ports on the virtual machine and forward them and in the container and forward them back to the Mac, then we'll have the same experience that we had with Docker Desktop, where it seems as if the ports are all available locally. And to do that, we need SSH port forwarding. So let me reset this, and we'll look at that next. In order to set up port forwarding, this is basically the idea. When I SSH into a remote server, I would like my local port 9229, which is the debugging port that we've discussed, right? I would like that, whatever's coming through that port, to come from the local host adapter on the remote machine. That's what I want. And that happens to be the debugger host. And for the purposes of this initial demonstration, I'm just going to load Podman. I'm going to invoke Podman. So I'm going to invoke Podman as a command in this SSH session, if you will. And instead of just running node, I'm just going to run bash in that container so we can verify that the ports, when I load node up in debugging mode on that remote container, they're visible on my local Mac using Devtools in that watcher status page. I hope that makes sense. Let me illustrate, right? So I'm going to expose port 9229, because these commands, everything Podman run here is vanilla Docker commands that you'll be familiar with, right? Except that I'm using Podman and not Docker to do that. I want the pod to shut down by itself. I'm using the node 16 pod container. But instead of using node, I'm just going to start up in the shell, in bash, right? I think that'll be helpful. And when I run that, right, so the port is already in use. If you have that port already in use, make sure that there's nothing else holding that port. Let's try that again. I made sure that things are shut down. There we are. Oh, so I'm in a bash environment on the debugger host. I'm in a container, I'm in a bash shell, and I've exposed port 9229. Now if I run node, now I'm in the runtime environment of node in the container. Now I can play around and load the inspector. I'm going to open 9229, and if this works well, this should show up as a exposed debugging port on my Mac. Let's make sure that that's good. All right, so the debugger port is listening. And the big question now is that port open, and indeed it is. So if I click this inspect, technically it should say debugger attached, and it does. So that's cool. I have the debugger using Podman without Docker, running a container with Node in debug mode, exposing ports, using port forwarding back to my Mac, just in the same way that Docker Desktop does. Now, I had an error earlier on which said that the port was closed, and that is because I had something else running that was holding up that port. So now that I have the port forwarding working, I have volume mapping solved, I have setting up the debugger solved, I have exposing the right ports solved, all these individual steps. And I know it takes long to go through each one step by step, but I'm breaking down how you would automate all these things. The next step is to take all of these and automate it into a bash shell script and see if we can get that to work using Podman. Let's just clear this first. Let's exit. Let's exit the container. And I'm back on the Mac and reset the terminal session. Let's go ahead and open up code in our folder on the Mac. Let's just kill the apps for a moment. Let's just go to the files. Right, so we've got two files here. Let's go ahead and create a file that's going to be our bash file. And let's call it remote debug. Right, so this is going to be a shell script. In fact, let's just put it in the root. Come on. There we are. Move. All right. I don't want to interfere with that. Right, so in this, the goal of this step now is all the steps that we've discussed at length is to automate them in a single shell script. So the first thing, let's create some parameters which we'll pass in. So I've got the mount folder, which would be the current working directory that the app is running in. We want to have some test files to make sure that things are mounted. We want to specify the default file to run. We want to specify the inspect options that we want to choose. We want to choose the image name, the container name, the host name, and the default port. Now, all of these will have default. So this is just vanilla bash stuff, right? And what we're going to do is I'm going to copy and paste the example that I've got here in interest of time. When you run SSH, you know how you can run SSH and execute a command after that SSH. It'll run at that remote machine and then return. Well, what do you do when there's lots of lines to run? Like in our case, we're going to do several things at once. Well, we use a thing called a heredoc. It's just a bash feature. And in a nutshell, it allows you to take a whole lot of lines that you create, put them into a variable that you can then append as part of an SSH invocation. And it handles multi-lines. It's a little bit easy to read. So in our case, what we did is we're going to SSH into the remote machine. Then we're going to create a specific directory that needs to be mounted. Once that directory is mounted, we want to verify that it's mounted. So we're going to create a test file in the local folder where we're running from to make sure that we can access it. If it's already mounted, then we want to make sure that we unmount it first. And this is part of that teardown. So a previous session might have left it in a mounted state. We want to make sure that it's unmounted. Then we're going to do an sshfs from the remote host back to the debugger client onto the mount directory that we're running. And then we're going to do a Podman run with all the various containers and options which we've discussed at length in the last several sections. We're going to put all of those commands into a variable and set up a little trap handler in case something goes wrong. And then we're going to do a SSH with port forwarding corresponding to the debugger ports. We want to make sure that if we are unable to port forward, that we want to exit. We would like to make sure that there's a terminal. If you don't have a terminal, then you're going to have some interactivity issues. And then all the various commands which we just put into that heredoc. And if we run this with the default commands, this should set up the debugging, set up Node in a debugging mode using Podman on a remote server from a Mac without Docker. So let's save this and verify that this works. All this code is available in the repo, by the way, so you can take a look at it. I think it'll take too long to type all this out, but I wanted to explain every little step and how we got to this point, and that's why it takes a bit of time. Now, once you've set this up, it's a breeze. You do it once and you're good. Debugging is a lot easier. So let's minimize that. Just one other thing we need to do is we need to create a file called isMounted. This is an arbitrary name. And here's the idea behind this file. When the remote server mounts back to this folder, it tries to access and see if this file exists. If this file exists, it knows it's correcting to the right folder and things are working. So it's just a little runtime test. At this point, we've got the remote debug shell, and let's make sure that that is executable. Right. Good. So let's see how this works. Just a few housekeeping things. Let's just make sure that the relative paths are correct. Here we are. Remember, we've got the code in a source folder, so we want to make sure that the relative directory, when you run node, whatever arguments you use here, right, one of them is the current working directory, and we must make sure that that corresponds to the folder that's mounted. Here we are. The reason that's also important is when the debugger is running and it tells the debugger client, hey, here's a script, it's going to use the relative working directory as a starting point. And so the client, which is Visual Studio, is going to have to be able to resolve that. So just make sure that that's right. So I'm making the default file to run to be source index and not just index because we have this source folder. So whatever structure you want to create and tweak this and customize and add whatever Podman parameters extra here are useful for your specific case, go to town. And that's the flexibility of this approach as opposed to having everything canned in one binary where you're stuck to its constraints. Here you've got basically using basic Linux primitives like bash and SSH to do all the things that Docker Desktop does with a lot more flexibility and a lot more power in terms of when you launch your containers in that Linux environment, you can set it up with specific users, the sky's the limit, and still have a great debugging experience. You don't have to sacrifice that, and that's the point. So let's try and test this out and let's see how it works. Let's just take and see what files we got. So there's my isMounted file. I've got a remote debug. So let's try and run this remote debug. But before I do that, let's just create a separate window here so we can do some remote evaluation of what's going on. What I'm expecting to happen is I'm going to run the shell script and it'll use the default parameters. It should launch a container in the remote debugger host. And by the way, that open connection failed. That's just an attempt to when you open up reverse ports and there's nothing sending information, it sort of thinks that there's no connection. So once the debugger started and connected and exposed those ports, that message will go away. Technically, what I should be able to do now is use Podman to see what containers are running. All right, so this should see if it's working. Well, there we are. So there's my container running on debugger host. So running in Fedora on a Linux host from my Mac, launched from my Mac. Now, the moment of truth, the big question is the port open? And indeed it is. So here's a cool thing. Maybe I could, well, let's do this. Let's launch the debugger client. And there we are. The debugger is attached. The workspace corresponds to my local folder. So, you know, everything's working correct. There's the source. You can see the little green dot, so code is working. I can now step through the code. So I've launched a container without Docker in debug mode on a Mac M1. If I let this run, it's going to finish. Now, if I terminate, the container should shut down, and then I'm back at my command line app. And if I look here at Podman, you can see that the container is gone. Now, if your container hangs, you can use all the commands that Podman has, which correspond to Docker commands, after this point, and control your environment. You don't have a graphical environment like Docker Desktop, but the debugging experience is identical. Now, so I'm going to close this out now, and the next step is to set up Visual Studio to launch this batch file. All right, or this script, if you will, this bash script. And then have it automatically connect to the exposed ports that we know are correct. Everything seems to be working well. Now, one thing that is important, all right, this SSH session, the reason why I've done all these commands in one session, as opposed to multiple individual SSH sessions, is that when this session tears down, it's going to tear down all of these things as well automatically. And that's helpful. So you don't have to fuss with that. And you can basically start a debugging session, stop it, shut it down. And when you launch it again, everything's not going to be locked up. That's an important experience element of this. And the automation needs to take care of all these little things. So that's why we did it the way we've done it. And I hope that is helpful. The next step, we're gonna close this out now, and we're gonna move on to automating VS Code to do all these things automatically. Let's bring up code. Okay, let's make these go away. I'm just going to select the app.js and select the debug tab. Part of automating VS Code, there are two things or two components that you'll use. The one is launch configurations and the other is tasks. Think of launch configurations as how to automate the launching of the debugger or starting a program. Think of tasks as just stuff that needs to be done, whether it's before or after these launch configurations. The different kinds of tasks. Docker has a plugin, for example, that exposes Docker tasks. And you can use these Docker tasks to launch containers. Well, we don't have that because we've got Podman. We're not going to worry about that. But to launch our containers, we need to first figure out how to create a task that can invoke the bash file. So the first thing we do is we just create a launch configuration, right? And when you select that in VS Code, it'll ask you what environment, and make sure that you select the node.js. What that's going to do is it creates this VS.VSCode folder in your solution. And in that launch JSON file, there are these configurations. It's an array of variables. And whatever you specify in these files, in other words, whatever the name is, when you run Visual Studio, it's going to appear in this drop down here. And this is what we use to launch Node.js. So instead of being prompted every time to select an environment, this is an example of using the PWA launch type, which is what we use for Node. That comes from the word progressive web application. It's the new Node.js debugger that is integrated into VS Code. There was an old legacy one called Node. Make sure that it's the PWA Node type. Now the schema and all the various options are available at this link, so you can go and take a look at that at your leisure. I'm not going to get into that. But suffice to say that you can change a lot of these parameters. So in our case, we want to look at what we need to do to launch this batch file. But in order to be clear about it, let's just call this debug local. So I'm going to debug on my local Mac machine, right? And that's just leave that as is because that'll just work. And let's duplicate this configuration. And in our case, we want to do a remote launch. So let's call remote debug, but we're going to use the launch option. The reason I specify launch, if you look at the request type, you can get an attach or you can get a launch. Typically attach is used if you have a running process and then you want to connect to it. Launch will actually fire up the whole environment, and you can, for our scenario, we can use both attach and launch because technically we're launching a remote container, exposing the ports and then attaching to that port. So they both work well. But the experience on launch is a little bit better from a familiarity perspective in terms of, being the same as the experience for local debugging. So I'm just going to keep this at launch as a request type. One of the options that we need to add here is attachSimplePort. So we know that this is port 9229 that we're going to bind to on the local host. And we need to also specify not the program, but the local root. So the local root is This helps to resolve the debugger file locations. And if you get this wrong, things will give you a lot of pain, a lot of headaches. So Visual Studio Code has these built-in variables which expand so that you don't have to type these things out and hard code them. It makes the solution portable across multiple folders. So the workspace folder is, in this case, this folder that we're working in, which is what? Print working directory. It's in users Mitchell node app. That'll be the same as the workspace folder. There's another option though. Let me just bring this down. And that is the remote root. Think of the remote root as the container's working directory. But we've set up, for our example, we've set it up to all be the same folder, right? Because we're creating that folder in the remote location. And when we get to, in a subsequent video where we're launching Node with all the best practices, in other words, we're making sure that we're running as the Node user, not root, all that kind of stuff, you'll tweak this example to make sure that the working directory of the container is running in the correct place. Because remember, if you're running as a Node user, it's not going, the target directory is going to be home/node, if that's the user that Node is running under. Anyway, I digress. This is what these two parameters are all about. And so you need to make sure that that's correct. And this will effectively try and bind to port 9229 if something's up and running. So the big question is can I do that out of the box? So let's just reset the terminal. I should be able to just launch the bash file from this location, right? Let's see if we have any joy here. This might not work, but let's try. So I'm going to launch remote debug. And now that's the debugger's running. So if I go here and let's say the default, we hard coded the default script to be index.js. Let's put a breakpoint here. Let's go here and see if we can do a remote debug and see if we have any joy. No joy. So what's the problem? Something's not working. We can see that there's an attempt to bind, but it's as if it exits immediately. Why would that be? See, it says here tell the debugger to disconnect. So we're not quite there yet, but we're on the right track. The bottom line is I'm trying to connect via that statement, right? Let's try that again. Let's run the session. So you can see now the script is able to run multiple times, which is a good sign. It means things are being cleaned up. Let's add an option here, which is stopOnEntry. So the reason this setting is important is what we noticed earlier on is it's as if things started up, but it's like there wasn't enough time for the debug breakpoint to be set and to stop. But this stopOnEntry, it uses the Debugger API. Remember that the node debugger exposes the API with the inspector protocol. Well, there's a command that says stop, go, move to next line, etc., etc. This is what is used to stop onEntry. So we're going to try again and see if we have any luck this time. And the reason this is important is this is a script that exits after it finishes. If you had to run the app example, which is a web server, then it wouldn't have that problem because it wouldn't just exit the container and then shut the container down, and it'll keep the debugging port open and you can try multiple times. But let's try this again. So remote debug, our much sought after debugging experience. Oh, what am I doing? Oh, voila, there we are. So I launched. I had this bash file which pre-launched, and I specified the launch configuration to just attach to that port. Now, if this meets your needs, you could stop at this point. And it's as if I'm debugging local, but guess what? I'm not, because the platform is Linux and I'm on the Mac. Now, if I run this, just let it run through, it'll terminate. So I need something to tell Visual Studio Code to launch that bash script automatically every time that I try and invoke a remote debugging scenario. But these are the parameters that you need for this. And in order to do that, you have what we call tasks. But the cool thing is that you can have a pre-launch task. And you can specify a name for this launch task. So let's just call it openRemoteDebugSession. But where is that task? What do we do? Now, this is where the tasks file comes into play. So let's just go into what we're going to do is we're going to create a tasks.json file. And this is where we put all the tasks. In that tasks, we can create an entry. Now, I'm just going to cut and paste from a canned example here, because it's a lot of typing, and I'll explain how it all works. Sorry, bear with me for a moment here. All right, so there's a lot of stuff here. Let me just explain what I've just done, because the format is important. And this is all documented, by the way, on the VS Code website. It's just, it takes a while to figure through, and I've sorted through a lot of these items, and I'll explain them all in detail, but I just want to make some space. I'm going to focus on this example. So we're looking for a task called openRemoteDebugSession, and so that's here. Then the format for this is also outlined at this link. And again, I said this code is in the GitHub repo, so you can go and have a look at it. You can look at the details of the schema. But this is a shell task, and what we're doing is we're specifying, let's go ahead and open our remote debugger. And then you give it any arguments. If you recall, we created the remote debugger file and we gave all these arguments, and one of those was the inspect break argument, and we said that was the third argument. Now, if you're good at writing bash scripts, you can tweak this to your heart's content. I'm just trying to keep it simple. The two args I'm going to give it is the workspace folder, the relative file, because I want to be able to debug individual files without having to hard code the file name. And this parameter in VS Code expands to whatever file you selected. So if I select app file, that'll be app file. If I select index.js, it'll be index.js. And it'll give me the relative location to the solution folder. And then I'm specifying I'm going to do an inspect and not necessarily an inspect break. And there's a reason for each of these, all right? So that's these basic parameters of the tasks file. Then there's this presentation section here. And all that is it informs you about how should we print out the information in the bash file into the terminal. And because when this runs in a debug session, it's going to create a new terminal. Right now it's in my default shell. right? So let's just reset this and go back a moment. Reset it again, so just to keep it clean. So I want to know, how should that running script print out in this shell? And that's what all those parameters are. It says echo whatever the terminal echoes, because I've set up the shell to have an interactive terminal. So whatever echoes out will be there. This says make sure that it comes to focus. Give it a dedicated panel. So you don't want to mix it with other terminal messages. And in cases where you reuse a terminal between multiple sessions, this just gives a little message to make it clearer to understand. And then when the script starts, clear it out. And when it's done, close it out. That's effectively what the presentation section is. So this is this terminal area, right? Now, any debug messages will show up in the debug console. And that's important also to note. And then there's this isBackground property. The reason why this is important is this shell script that's going to run is not going to finish and then return control back to VS Code. It's going to launch the container and it's going to kind of be in a holding state. And for that reason, we want it to be a background shell script. This is kind of a big important setting. If you don't make it a background, what will happen is Visual Studio Code will wait for that script to complete. But that script's not going to complete until the attach is debugged. And so the launch task will, before it tries to bind to port 9229, it's going to wait for that to finish. But that won't finish until it binds. So it's kind of a chicken and egg scenario. So you solve that problem by creating a background task. But the problem with the background task is Visual Studio then doesn't know, well, at what point do I go ahead and attach to port 9229? And that's called a problemMatcher. It's a strange definition. But in a nutshell, what it's doing, if you understand how VS Code uses tasks, it uses tasks for things like linting and background tasks that run all the time in VS Code. And so it's going to try and tie into outputs of these commands, be it maybe it's TypeScript or some compiler. And so you want to give it a queue based on some output of that task that is being echoed into the shell, into the terminal, what to look for before it does a binding. And that's what these patterns are. And the key thing here is we're trying to say, look, we're not looking for problems in our example because we're not trying to lint the code or something like that. We just want to wait for the debugger statement to say that, hey, I'm waiting for the debugger to connect. And so when it comes to the pattern to search for, we don't want to search for anything. The key thing that we do want to look at, and the patterns in terms of problems, but the key and the cue to go ahead and know when the task is beginning and when it ends, right, is it's going to do a regular expression on this text. Now, when we run our terminal, that's exactly what we're outputting. The last thing that the shell script puts out is the debugger is listening on the socket 0.0.0 blah, 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 right? All that stuff. So we just want the beginning of that as a queue. So when that pattern is matched, then VS Code's going to know, okay, at this point, I'm going to go ahead and attach to this point and issue that command. So that's how you manage the timing and create a good experience. So that's the task. And this is this specific task is the openRemoteDebugSession. But now we have a problem. There are cases where we want to, if we have a script like app.js, right? This code doesn't exit. It doesn't exit in the same way that this code exits. This runs and then exits, all right? And at that point, the container shuts down, the SSH session shuts down, and so forth. In this case, this just stays running because it's in a loop. So I need a way to shut down the container. So docker stop or podman stop with a container name is a command I want to issue. And that's why I'm going to create another task called closeRemoteDebugSession. That's for these cases where you're shutting down it. And all that I'm doing here is it's a shell. And I'm just going to say podman stop node debugger. And the node debugger, I've used that is because that's the name of the container, right? So whatever container name I choose, all right, that's going to be that property. And when it is done, I want to exit with a 0. Now, the reason why I have that as a separate bash command, sometimes that doesn't always shut down clearly and it throws a terminal error. And then the bash will exit with a non-zero code, and that's going to pop up dialogues in the VS Code environment, and we don't want that. If you want to see those errors, yeah, just remove that statement. The presentation statements are the same. This is not an asynchronous task because we actually want this to finish completely. So this close remote debug session, what we're going to do here is we are going to have the pre-launch task, and then we're going to have the post, was it after debugging task? Post debug task, I think. Here we are, post debug task. And we're going to give it a name. All right. So that tells these two tasks, okay, before you start a debugging session, do these things. After the debugging session, do these things. You may also, for your scenario, have a whole lot of extra cleanup code. You could go also and create an async task if you wanted to, with a whole lot of here now, multiple line statements to clean up. Whatever cleanup you need, do there, right? The problemMatcher, I just want to point out that if you don't follow this exact pattern, this is a minimal problemMatcher statement. If you don't have this as here, as a starting point, this background will not work properly. I've just found this out by trial and error. This is the minimal set of settings you need for something to work if you want to run a shell script in a way that's helpful. So just pay attention to that. Use this as a template. There is another task that I also created, and this is really just a duplicate of the openRemoteDebugSession. The only difference is in that case, I'm using the inspect break option. That's the only difference between these two tasks. You can probably optimize combining these into one task if you want, but I use them because it caters for different scenarios. When I'm doing a break debug and I'm trying to debug a script that exits, I may want it to break on the first line as part of my debugging workflow. So that's how you would do it. This is the same task, it's just different by it's effectively doing the stopOnEntry automatically, and this is doing the stopOnEntry as part of the launch. Now, if this all works, technically, I should be able to set my code. Right, actually, let's select index.js because I have to select the file now. And if I debug that, so it failed to launch. Why did it fail to launch? Right. So this is you run into this sometime. The problemMatcher is trying to find something to match, but it seems like it's going too fast. Now this is effectively saying that the problemMatcher couldn't find anything. So before it attaches, it's waiting it thinks the script is running and running and running. Now I can choose to debug anyway. And I may connect to it or I may not. But if I shut this down now, it'll execute the task that debugs, shuts the pod down. So let's go ahead and, because there's a problem here somewhere, and let's try and figure that out. Let's go ahead and create the third type where we do an inspect break option and see if we have any success there. I've got it again, a canned example here just because it makes typing all this a little bit easier. So in this example, I've got another debug task, and instead of calling the openRemoteDebugSession, I've got openRemoteDebugSession and stopOnEntry. So I'm calling the difference. So I'm trying to execute on the first line, and I need that for this scenario. So let's see if we have any success there. stopOnEntry, and let's see if this works. Still having a problem. So something is not right with the terminal process. What could that be? So this is helpful to illustrate when you're trying to debug or troubleshoot why the script is running. Let's go back to our task, and remember we had the problemMatcher and we had the presentation. One thing that we do is we close the terminal when it's finished. So let's set that to false. And the reason for that is we'd like to see what is going on in the terminal. What's the message that should be showing up in this terminal? Save that, and let's try and launch this again. Still terminating. So we keep getting this error, and we have to try and figure out how to solve it. Go through your tasks. Make sure that the task that you're running is identified. So we've got closeRemoteDebugSession. All right, so that's not the thing that we're worried about at this point. Let's make sure that, all right, the terminal is shutting down. Let's look at the next one. We see, okay, this is the openDebugSession, and we want to make sure that that's not closing down so we can troubleshoot it. And openRemoteDebugSession stopOnEntry, which is the scenario we're tackling right now. We want to also make sure that the terminal is not available, right? So when you run this scenario like this, when you've turned off that flag, all that feedback from the terminal will show up here. And you'll see here, terminal will be reused by tasks. Press any key to close it. That is this show reuse message. And basically what it's complaining about is, look at that. The joys of copy and paste. Launch remote debugger shell. So when I copy and paste, I've got remote debug as my name. Let's just say launch remote. So I'm debugging the debugger. What was it? What is the name of the task? There we are. Let's just make sure we get this exactly right. All right, so I think it'll make a sense why it wasn't working. When we run the bash file from the terminal, it worked fine. But when we're trying to integrate it with VS Code, it wasn't working. So these are the little things that you need to watch out for. And that's why it can be a little bit painstaking. But once you get it working, it's great. So now once this is off, let's just turn these off. Now, because if you don't turn that message off and don't close the terminal, you're going to get this message every time. And so you're going to have to come in here and say, okay, I'm done. And we don't want that. It's just annoying. But nevertheless, it's helpful for debugging. Let's make sure that that's right. All right. Close that down. Now let's bring up our index file and see if we have any success now. All right, stopOnEntry. Run. Oh, there we are. There's your F5 experience. Now, notice that this red square, that tells the debugger to stop. Now let me just, I need to just point out a few things here. This is the terminal that was created. You'll notice there's two terminals here. There's this original terminal in VS Code, and then this remote terminal. And that is because the task is a bash task. So openRemoteDebugSession, this terminal is whatever's in this is shown in the way that you indicate here. And over here, you will notice all the various commands that were used. So I can see exactly what was run. And depending on how much output you put in your variables, so if I go to the bash file and put a whole lot of echo statements in here, then I can show the user exactly what commands are being executed remotely. And whatever I print out and echo in this bash file is going to show up in this terminal. So that's just a debugging the debugger tip to remember. All right, so the debugger is attached. In this case, I now have fully integrated debugging. I can use the code as if it was local, but it's actually running in a remote container launched from Podman in a VM that's remote. Now, when I stop that, take a look at this area, pay attention to this area here where the terminals are, and you'll notice that the closing Podman task executes, closing remote debugging session. It's very quick. So let's try the app.js. Now I'm just selecting a different file, and I'm going to do a launch on startup, right? So stopOnEntry. And the reason is because the HTTP server that I'm running here is going to start, and then it's got a callback. And so I want to be able to have breakpoints inside the HTTP server to handle requests. And I want to be able to start up. And the problem with setting a breakpoint just on launch, it'll never catch that first line of code. It's just not fast enough. There's a issue there. So that's why I created those two tasks. But let's do a remote debug start on launch. And this is the web server example. And notice now, I didn't have to go in and reconfigure my scripts. Whatever file I select, I debug. If I continue this and I go to my default terminal, I can now say curl localhost. Well, actually, this would be, did I forward this port? I'm not sure if I forwarded this port to in when I set things up. Let's just do Fedora host, because that's the name of that machine. And let's see if, so there we are. So I can now invoke my web browser, and I'm handling a scenario where I have a long-running server. Cancel, I beg your pardon. We want to run that. So this is a scenario where the process will never terminate. I have to self-terminate it, so I can send it a Q command and it will terminate. But you don't always have that. So this is where I need the stop debugging task, right? Or shut down. Where is that task? Here we are. That's where I need this. Because if you go into the terminal, I need to effectively do an SSH Podman stop, shut down the container. But I've automated it already. So when I click that, my container is still going to shut down, and everything, it waits for it to shut down and clears up itself, and everything is clean. And I can go in and start a new debugging session. Everything continues to work. It's re-entrant. I keep clicking the wrong button. And I'm good. Now, if I had to try and use the launch option task, I never get to catch that first line. See, it starts, but it won't break because it's too quick. So I can say debug anyway, but even then it didn't catch a breakpoint. Now, if I do a curl, it is the debugger is set up. Oh, I beg your pardon. There we are. So the debugger is running. It just doesn't catch that first example. And that is why, again, I just want to emphasize, that's the difference between these two tasks. I keep going to the wrong place. That's why I have inspect versus inspect break, which will force the debugger to stop on the first line of code that it executes, which in this case happens to be this line 1 in this web server example. So this has really been a long drawn out session video, but I've tried to explain all the little details and why things are done the way they are. But I think you'll find it helpful because now once I have this set up, to debug this, I can add code, I can add everything. I don't have to do a Docker build. I can just debug the code on my local machine. Now there's one caveat here. When I have external node modules, right now everything's JavaScript, right? So Node is portable. Node will run on ARM, it'll run on Intel. But certain packages do a compile step, and they are platform specific. And if you're trying to debug a platform specific node modules package as part of your application, well, then there's going to be some extra intermediary steps where you do a Docker build. So it'll build on what is done here, but just remember that that's going to have problems because compiling for ARM is not the same as compiling for Intel. And some node packages do a compile and a build. I'm assuming that I have no node modules here. And if you do have node modules, the ARM CPU or the ARM node process is going to use the node modules on this machine. So if it's an ARM server, that's fine. But if it's an Intel server, well, then it's going to be a problem. So just bear in mind that that's how that works. So in a nutshell, that's it. Let's just close the tasks. I have a scenario here where if I had done all these steps and I've got this all configured, my experience, which I started out at the beginning of this session, says, hey, I would like to have an F5 debugging experience with no Docker at all, just Podman on an M1 Mac and either an Intel remote machine or a ARM remote VM machine And the proof of the pudding is setting a breakpoint, pressing F5, make sure I've got the right task set. There we are, F5. So that's my F5 experience, integrated debugging, and we're good. We're golden. So to wrap up, I hope this has been useful. If we go to the original slides and we look at where the code is, there's a GitHub repo that contains this example. And it doesn't have to be this long. It doesn't have to be this difficult. It's actually very easy once you know how to do it. But I've gone in great depth showing you every little detail, trying to dot the I's and cross the T's. Take this and explore it, modify the remote debugging scenario, experiment with that using your own flags, tweak it to your heart's content, and I hope you have a great debugging experience. I'm going to call it quits at that. This has been a very long session, but nevertheless, I hope it's useful. In the future, I'm going to create some more videos targeting best practice scenarios. That's node.js with the correct credentials. I'm also going to be creating some videos about going through this process for Go binaries and Python binaries. And then also what Podman brings to the table that Docker doesn't have is that you can create containers that, not just containers, but pods, right? A pod is more than one container that share common namespaces. And it's the precursor for how containers work in Kubernetes. Because the end game of all of these series of debugging is how do I have this great F5 debugging experience in Kubernetes? And how does that all work? So we'll touch that in subsequent videos, but that's obviously another session. So let me know, give me some feedback where possible, and I hope it's been useful.